Hello and welcome. As explained in the first episode, I want to start this project by connecting a single sensor to an Arduino and see if we can pull measurements from it. I'm Berard, this is a DH222 sensor. Let's program this thing. First step is identifying the parts. We'll need some DH222 sensors, so I ordered those. My wife had an Arduino Uno lying around, so I borrowed that. Found a breadboard next to it, so might as well use that. Throw some wires at it and Bob's your uncle. Let's draw it with a bit more detail. An important note to start with is that there are two different DH222 sensors. One has 3 connections and the other has 4. My sensor has 3, so I will be covering that. And I will be using a breadboard to connect everything. This makes it easier to expand to multiple sensors later on. In case you don't know what a breadboard is, it's a panel with internally wired connections. This means I can plug wires into the same channel to connect things. The red and blue horizontal lines are connected, just like the vertical lines up until the center. Let's put the Arduino, breadboard and sensor on the screen. First, connect the sensor to the breadboard. In practice you can just plug it in, but I will draw wires here. Power's next, connecting the Arduino 5V to the ground to the plus and minus channels on the breadboard turns the channels on the breadboard into a power hub. Connecting the sensor plus and minus to these same channels and the power's done. Only step left is the data. Since channel 2 on the Arduino is the first free one, I'm using that one. And that's it really. I'll connect my other sensors as well, since we're working with cables now anyway. This is done exactly like the first as seen on the schematic. Pause the video now if you want to take a closer look. On screen now is a picture of my setup. Except for the connection to the PC, which is one simple cable, everything is done. That's seal of approval worthy. Let's start programming. For this I am using the Arduino editor online. Reading a DH222 sensor has been done plenty of times already, so I'm using code from Michalis Vasilakis. In my opinion, even when using code from the internet, it is important to know what it does exactly. This allows to adjust it to your specific needs. I try to run through my code in a beginner-friendly way, but if you still have any questions, let me know. Either me or someone else who reads it might be able to help. The code starts off with a comment giving credits to the creator, followed by importing the DHT library needed for our DHT sensors. In the constants part, we define which pin and sensor type we use. For variables, we define all variables we need to store data. Since we measure humidity and temperature, we need variables for both. Defining them as float allows for decimals. For the setup, we set the value to the same number as in the monitor. What I read, this value is standard and doesn't need changing. Now we get to the core of the code. Everything in the loop chapter is repeated. First, humidity and temperature are read and stored in their variables. Then we print the variables. Text and variables can't be printed in the same command, so it's split in 5 lines. Everything between quotation marks is printed as is. Without the quotation marks, it will print out the value of the constant. The println forces the next print on a new line. And finally, a delay. The value is in milliseconds, so 2000 is 2 seconds, which is the minimum for a DH222 sensor. Verify and save the code to check if it's okay, and we can test. Connecting the Arduino to a PC is quite easy. Connecting it using the USB cable provides power as well. You'll need the Arduino agent next. This is downloadable from the Arduino website and is needed to detect the Arduino. Once it runs, you can pick a port and a board in the menu, and the upload and save option becomes available. Once it's done uploading, it will start to run immediately, and checking the monitor, we can see it's working. Next step, making sure all the sensors are working. We can repeat the code for each sensor we have, and for 3 sensors that's achievable, but I want to have more sensors in the future, so let's design it a bit more scalable. Starting at constants, we'll need to define all pins. Below that, we see the first example of scalability, a matrix. Instead of a single value, we have 6 values in a 2x3 table here. The new string room names is an array, which is a 1x(n), in this case 3, matrix. I can use the array to save all names of the rooms where I'll put the sensors, and for now they're placeholders. After defining our humidity and temperature as arrays as well, we can dive into for loops. Loops repeat a certain part of code until a specific statement is reached. I use 2 identical loops, one to read all sensor values and one to print all values. The loop is the default counter for, in this case, 3 iterations. It sets the value of variable I to 0, where the I is a programming standard for cases like this, but it can be changed to anything. The next statement says the loop should continue as long as I is smaller than 3, after which the value of I is increased for each run through the loop. Within the loop we see the added value of the arrays and the aforementioned I. The value within the square brackets determines which position of an array or matrix we interact with. Remember that the first position of an array is 0, not 1. The value can be replaced by a variable, so using the I we just defined in the loop, we will cycle through the positions of the array whilst we loop through the code. Next step is easy. The loop is identical, so for each sensor the code will be executed. The room names have been added, and the delays increase because 3 lines of text every 2 seconds seems a bit much. And that's the end of the code. Only thing left to do, test it. And there we go. Now we all know for sure it's a comfortable 20 degrees in here at the moment. Noticeable now is the difference between the sensor values. This would be a good time to talk about 3 important properties of sensors: range, resolution, and deviation. The range is obvious. As long as the measured value stays within the minimum and the maximum value, the sensor will work as intended. The resolution tells us the smallest change the sensor can detect. Since the values have 2 decimals, it is tempting to assume the resolution is 0.01. However, you can see that the last digit is not used, meaning the resolution is 0.1. And finally, the deviation. This gives the range around the measured value where the actual value will be. To visualize, let's put the measured values in a graph, add the given deviation above and below, and mark the range all sensors agree upon. The actual temperature and humidity will be within these ranges. You could use more sensors to narrow down the deviation, like I've done here, but when I'll install the sensors in the rooms, the deviation is fine by me, so I won't install multiple in the same spot. And with that, we've completed 2 blocks of the plan. Next focus will be the network connection and the computer readings. For this I will need an Arduino with a network connection, so when it's here we can look into sending readings to my PC from anywhere in the house. Thank you very much for joining me, and I hope to see you in the next episode.